Good morning, good afternoon. Today we're going to be going over problems 3 and problems 4 from page 159 in Unit 3 of your book. Problem 3. The Terrapin Candy Company sells its specialty turtles made from pecans, caramel, and chocolate through orders placed online. The company webpage shows a table of prices for sample orders. Each price includes a fixed shipping and handling cost plus a cost per box of candy. So if we look at this problem, we have two things. There's a shipping cost, and then there's a cost per box of candy. So problem number 1 says, why is this a linear function? And if we look at our table of values, what we want to be checking for and seeing is as our table is increasing, when we divide the increase in our dependent variable, so this was going from 12 to 35 plus 15, by the increase in number of boxes, is it the same? So we would have here 15 over 1. And is that going to be the same for all of these changes? It's going to be the same from here to here, and from 50 to 60, and 3 to 4 boxes. And then last, notice that this is a larger jump, from 5 to 10 and 80 to 155. So let's go over here and let's just text this out because so far it seems 15, 15, 15. That seems pretty standard. Let's just double check this last value, make sure that's also linear. So that would be a change in 75, and then this would be a change in 5. So the last thing we want to check is 75 divided by 5 equivalent or the same as 15 divided by 1. So let's just check this out. 75 divided by 5, boom, we end up with 15. So we see that this seems to be a linear function. So let's type that up. So maybe we wrote something like along the lines of A on our paper, this pattern seems to be linear, and this is probably way too large. Let's make this smaller. Okay, because the rate of change is constant at 15. And that's what many of the students I saw that got to this problem, that's what they wrote down. Part B we kind of already have answered. Part B is asking what is the rate of change in order of price as the number of boxes increase, okay? So we can go ahead, we can answer that also, right? So we could say for B, maybe somewhere on our paper we could say the rate of change, again, I don't want this to take the whole thing, so rate of change is 15, and it's what, $15 per box of candy. Notice how it's more than just a number, we're describing what that means. Make sure you have that written down on your paper. Next part says here, write a rule. So write a rule, so that is a for here, and we're using the price, P, and N for boxes. So our rule is going to look something like, let's see, so for C, our rule is going to look something like P equals something plus a blank N times N, something like that, right? So for our rule, we're going to say, we're going to type this in, the price is equal to, well, I don't know what that is, what that starting value is, plus 15N. So what we have to do is we have to figure out what is our starting value, and that would go right here in the table. If there was a 0 in our table, that's where it would go. So let's just look at our table real quick, and I don't want to do that. I want to do this. So let's in our table, let's do this. I don't want to fill it. I want a pen, and I want to use a color pen. I'm going to use a white pen. So let's see. So let's, because I'm going to kind of, I know, right, and let's just, because I'm going to put a number here. So if our table could go back to 1, and that makes sense, 0, 1, 2, 3, we're following a pattern here, what number would go right in here? So we want to think, what number plus 15, because we're only changing 1 here, is going to give us 20, and that number is 5. So that tells us our original cost is 5. So our starting value is 5, and we look up back at the problem, this is going to be our shipping and handling cost, probably, right? $5 shipping and handling plus $15 for each box. So the next one So that takes care of that. Boom, done. C. So we got A done, B done, and C done. Now D, use your rule to find the price for 6 boxes and the price for 9 boxes. All right, so if we're doing 6 boxes, we're going to be using our, we don't need any of this. If we need our 6 boxes, we're going to be using this equation right up here. So let's write it out. So we'd have our price for 6 boxes is equal to 5 plus $15 for each of the 6 boxes, right? And that's what we would do, okay? And we would just do this in the calculator. All right, so I have a calculator right here, so let's just make it happen. So let's plug that in. So we have 5 plus 15, boom, 6, enter, and we get $95. $95, boom, $95 symbol. All right, so that's our first answer, and the price for 9 boxes. So for 9 boxes, we'd have the price for 9 boxes is 5 plus 15, okay, and instead of having the N here, instead of replacing it with a 6 for the 6 boxes, now we're going to replace it with a 9 for the 9 boxes. 9, all right, and that's going to give us our answer. So we could just go over to our calculator, 5 plus 15, 9, boom, we get $140. Okay, so you can ask yourself, would you pay $140 for 9 boxes of candy? Put yourself in the problem. Would you do it? All right, that kind of wraps up this problem, our problem number 3. All right, and we're going to move on to problem number 4. That's my arrow. All right, here we go. Problem number 4. So the Washington High School store sells bottled drinks before and after school and during lunch. So during the first few weeks of school, the store manager set a price of $125 per bottle, and the daily sales were $85 per day. And then they changed the price, and they said, oh, now I'm going to do it for ooh, that's ugly. Okay, they changed the price. They said, now I'm going to do it for $175 per bottle, and that's still ugly. Let's make this happen differently. Okay, $175 per bottle. And the price decreased to 65 bottles per day. It says, what is the rate of change? Now, we're used to seeing rate of change in a table. So I'm going to go over here, and I'm going to set up a little table. And I'm going to say, on the independent variable here is going to be the price. Let's see, right here. The price. And then, and I guess we're doing this in dollars, right? And then this is going to be how many bottles sold, right, on that day. So we're going to set up our table. So, and I'm going to leave a lot of space here, and you guys will see why in a second when I go to do this. So we're going to put this in. So when the price is $1.25, 1.25, all right, then the bottle sold was 85. But then when they do an increase in price, 1.75, the bottle sold went down to 65. Okay, so what is the rate of change? This is where we just do our math and we just divide. We think, well, what is the change in our dependent variable? Well, that goes down 20. And what is the change in our independent variable? Well, that goes up 50 cents. And we're just going to divide those two numbers, right? That's 0.50, 0.50. Okay, so we're just going to divide those two. So we would say for our answer, let's go over to our calculator. We're going to divide negative 20 divide by 0.5 or 0.50, okay? And we get negative 40. So our rate of change, okay, let's go type this up. Let's make it happen. A, okay, so our, I guess I'll have to fit it right over here. 8, okay, A, all right, the rate of change, and this is already like, it needs to be smaller. Rate of change for this is going to be, time is what? Negative 20. 20. Okay, the units would be, well, what do we divide? Bottles per dollar. That's it. That's kind of how the units we would, that's the units we would use. Okay, B. Okay, assume the sales are a linear function. Use the rate change to reason by expected daily sales for a price of 0. So this means what happens if our table goes all the way back to 0, all the way back. So we have to kind of fill this out and think about how would we extend this pattern. And I would take a minute and I would pause the video and I would stop and I would say, try to do that on your own. What goes? 65, 85, and then kind of what goes next. All right, so hopefully you kind of worked through that and you were able to think and kind of count back a little bit and notice that we have a pattern here: 65, 85, 105, 125, and this pattern would go from 125, if you subtract, it would be 75 cents, and then 25 cents. Now, if you continue this pattern, you're actually going to skip over 0 because you're going to go from 25 cents down to negative 25 cents. So negative 0.25 cents. All right, and that's a problem because we're looking for 0, not that. So we have to think, and this is where it becomes a little bit of a challenge. You have to think, well, what if this is 0? So notice that we're adding 50 every time, right? Adding 50 cents, adding 50 cents, and adding 50 cents, okay? And I don't even care what this number is because we're not going to use it anyway. So adding 50 cents. So what would happen, and every time we add 50 cents, we decrease by 20, right? It goes down by 20. So what if instead we only added half of 50 cents? If we only added half, so 0.25, this is where it's like a real challenge. So instead of going down by 20, from here to here, we're only going to go down by 10. Look at that. So what minus 10 is 125? Think about that. So you should get 135. Okay? And that gives us our answer for B. So B, for B, we're saying, let's see, the sales for a price of 0. So the let's make this the right size. The sales for a price of 0 is 135 bottles. I don't have a lot of confidence in this, right? If you think about this, there's not a lot of confidence because if the bottles are free, I think more people are going to take advantage of them and are going to participate in that. So let me just make this a little smaller so it's not in my way. All right. So I have little confidence in that. So it says how much confidence in that prediction? I have little confidence because if the drinks are free, more people will consume them or buy them. I'm going to put that in quotes. Okay? So we got A done, we got B done. Now part C, it says use your answers in part A to write a rule for Y. So the sales are in Y. So here we have sales Y for any price X. So we would have, let's put our answer down here, C. So we have Y equals blank plus blank and then X, right? Where this is our, just kind of going through this right here is our sales, and this is our, sales mean number of bottles sold, and this is our price. X is our price. See, X is price, that's sales. Cool. So we can go ahead, we can fill in our numbers. So we know that the initial value here is 135, so the initial value is our constant term. So we put that by itself. And then we know that the rate of change we got all the way up here was negative 20. So we put that into negative 20. Boom. So I'm just going to fill that in the blank. All right. And then I'm going to choose to kind of rewrite this because I think when you have plus and negative, that's really like middle school stuff, plus and negative. We're way past that. So we have Y equal 135 minus 20X. Boom. And that's our answer. That's a good one. That's the good one. So that's our answer. So let's highlight it, if that'll work or not. All right, so I'm noticing we're near our time cap here. All right, I'm noticing we're near our time cap here with our video, and for some reason that's not working, but let's read through this. So use your rule to estimate the expected daily sales if the price is set as 0.90 cents per bottle. Okay, so 90 cents per bottle, so that means the price, this X, is now going to become 0.90. So we're going to replace this X with 0.90. So I'm going to come over to my calculator, and I'm just going to use this rule. So I'd have 135 minus 20 times 0.90, okay? And you just replace the X with 0.90, and this should be our answer for D, okay? Oh, look, it did catch up. Good. All right, so that's our answer for D. So let's write this up. Ooh, I'm like down to the last minute. D. Okay, for a price of 90 cents, there will be 117 bottles sold. Okay, and that's another example problem, a good one to practice for your quiz coming up. you know, it's a good kind of like lots of different steps that we went over in here, lots of finding the